How does our ocean work and why are the currents flowing like they're flowing? In today's episode of Sea Stories, we want to look into a few basics of oceanography. Oceanography is the science that is investigating the ocean. It's a lot of physics, but it also means that you get to go out on a boat to observe the ocean and learn about its properties, its movements, and also the life therein. Typical physical oceanography is focusing on the currents of the water, the temperature of the water, and in particular the salinity of the water. So why is a sea ice physicist interested in the ocean? Well, of course, the ocean is also transporting heat, and this heat can melt the sea ice. And of course, if the ocean is cold enough, we can form sea ice. So for us, the underlying ocean is always a very important boundary condition for the evolvement of the sea ice. So what is driving our ocean circulation is actually, in the basics, a very simple thing. So like with the weather on this planet, where pressure gradients between weather systems are driving the air masses around the planet, this works just the same also on a large scale in the ocean. Another thing about the ocean that you probably know is that ocean water is salt water. It's not like the lake that you go to swim in during summer. When you go to the coast and swim there in the summer, you will feel this very salty taste of the water. It often burns in the eyes, and this causes a lot of particular properties of the ocean. One of the main interesting factors of why we are interested in the salt content of the ocean, or what we term salinity, is because ocean salt content determines the density of the water. So the more salt is in a water, the denser the water is. And now you have maybe heard in school that if you have two liquids that have different densities, then they can actually be floating on top of each other. And this we can see in this little video. There is very salty water in the bottom of the tank, and now once after the other I am adding fresh water to the tank, and I do it very carefully, so you can actually see how the fresh water is slowly accumulating in the tank. And when I've added enough fresh water, you will actually see that there is two different layers. So we have a freshwater layer that is floating on top of the salty water. The other property that is very much determining what is happening in the ocean is, of course, the temperature in the water. Because colder water is also denser than warmer water, that means that colder water sinks down underneath warm waters. And on this video we see what happens when I put some ice cubes into some ocean water to cool it down. And the ice cubes here are colored blue so that you see what is happening to the water. And you can see when those ice cubes melt, they cool down significantly the water around them, and this cool water sinks down immediately. And this is one of the things that is driving our ocean circulations. Another very important factor driving ocean circulation are the winds. So you can imagine that if a wind is blowing over the ocean, it is taking the water with us. So if we take again our little test basin and consider this is the ocean, and we have a wind coming from the right side, then you will see that the ocean water at the surface is actually moving along with the wind. Now, once this ocean water that is moving is hitting a topographic boundary, here it's the boundary of the tank, but it could be also a continent, this water might actually be going down to the deep sea and then flowing backward. You can see that the water starts going in circles. On the top it goes along with the wind, and further below it takes another direction. So there's actually some bigger circulation movements in the global ocean driven by the winds. While in this video we added some color to this circulation pattern to make it visible, you can also look at this video where we have just two water layers sitting on top of each other. And here the impact is not so great directly but the wind is coming again from the right side, and you can see how the interface between the two water layers is very slightly getting tilted, because the wind is moving the water again in a circulation, which leads to a higher pressure on the left side of the tank and the lower pressure on the right side. This means that the denser water on the right side is actually rising up a little bit. And if we now add some water back to it, we see that there is a convection movement going on in this uppermost cell, but just that the wind blowing away from the land is also pulling up water masses. Now we're coming to a very particular case. So in this tank experiment, you see that we have a very nicely stratified water column. That's what an oceanographer calls a water column, where we have two types of water sitting above each other. So we have a rather fresh layer sitting on top, and a rather salty layer sitting on bottom. Now we have a glacier, for example, going into a fjord, and this glacier is discharging some meltwater down into the fjord. And because it's a floating glacier, it is discharging this water actually at the seabed, so at the bottom of the fjord. Now, of course, the glacier is made from snow, so fresh water. So the discharging water is also fresh water. And once it gets into the fjord, it is rising. And here you see how this fresh water is hitting the dense water and pulling up, rising to the surface, and within that it actually entrains and mixes with the deep water layer, bringing up quite some deeper waters. So this was a quick overview about the most important processes that are driving our ocean circulation, and you can see that ice can have a quite significant impact on the ocean circulation, and that's why we are also interested in studying the ocean. I hope today you learned a bit about how our ocean is working, and with that I want to thank you for watching and have a nice day.